This is OCR, paper 6, November 2017, and it's a calculator paper. Okay, so I've got a calculator with me. It says use the formula S equals UT plus a half AT squared to calculate S when U is 5, T is 10, A is 3. So S, UT, that means 5 times T, so it's 5 times 10 plus a half times 3 times 10 squared. So first of all, I've substituted in U5, T10, and that means multiply them together. Then it's a half times A, so it's half times 3 times 10 squared. I'm going to type that straight into my calculator. In fact, I'll do that in my head because so it's 50 plus 1.5 times 100. Okay, so I've done the 100 and 1.5. So it's 50 plus 150, which is 200. Make A the subject of the formula. So to do that, this means that we've got S is the subject of the formula here in terms of UT and A. We need to get A in terms of S, U and T, the other letters. So there's two ways to do this, so I'll do it both ways. We can think of, we start with the A, and then it's multiplied by a half T squared. See, A times a half T squared. And then we add on to it UT. And out comes S. That's the formula. This is what happens to A to give an output of S. S is UT plus a half AT squared. So it's A times a half T squared. And then we've got to add UT. So then we can say, if we start with S, and then we take away 2 UT, and we divide by a half T squared, that will come A. So we go, what happens here is we go backwards. Minus UT, and then divide by a half T squared, and that will come A. Okay, now that is an answer, but if we divide by a fraction, we turn it upside down and multiply. So we say A, this is therefore A equals S minus UT divided by T squared, and then turn it upside down, multiply, times 2 over 1, so it's 2S minus UT over T squared. That's one way to do it. The other way you can do it is, we start with the formula. I'll write it the other way around with the A on the left hand side of the equals. Okay, this is an or, you don't have to do it both ways. So I've written the right hand side first and the equals S. So then we can subtract UT from each side and then multiply by 2. Multiply both sides by 2 and then divide through by T squared. Okay, 2S minus UT, all divided by T squared. Question 2. Carla runs every 3 days and she swims every Thursday. On Thursday the 9th of November, Carla both runs and swims. What will be the next day on which she both runs and swims? Okay, so she swims every 7 days and she runs every 3 days. So we actually want the lowest common multiple of 7 and 3. Now 7 and 3 are prime numbers, so that is going to be 21. So she's going to next run and swim together on 21 days. 21 days time is going to be Thursday the 30th of November. Okay, and that would be your answer. That's the answer in there. I'm not going to rewrite it to save time. 21 days time, because it's 9 November plus 21 days. And it's going to be a Thursday because it's got to be a swimming day. Okay, a shop records the time taken by its customers to complete a purchase on its website. The results from one day are summarised in this table. So we've got the time taken. So 6 customers took between 0 and 3 minutes, including the 3 but not including the 0. 10 between 3 and 6. 6 between 6 and 9. 2 between 9 and 12, and 1 between 12 and 15. Okay, so if you notice the lower one here is actually included in the one above because of the equal sign there. So that 6 is in there, but that's the starting point for that one. Okay, so it does say calculate an estimate. Let's get a nice colour for that one. Calculate an estimate of the mean. We can't get the exact one because we've been given them in groups. So for instance, we don't know exactly how long these 6 customers took, but we just know that between 0 and 3. That's why we can only calculate an estimate. So the estimate of the mean. So because we don't know how long each of these 6 customers, or in any of these categories, how many of those customers took, we just do at the middle point of these. So that's going to be 1.5 minutes. Okay, 3.5, 7.5. To do these, if you can't do these in your head, I'll come back to that in a minute, that's 10.5 and that's 13.5. If you can't do these in the head, you do 0 plus 3 is 3 divided by 2, 1.5. 3 plus 6 is 9 divided by 2, 4.5. Oh. 6 plus 9 is 15 divided by 2, 7.5. And then that's 21 divided by 2, 10.5. And that's 27, 13.5. Okay, so when we do a mean, you have to multiply number of customers by the midpoint. So these 6 customers, each on average took 1.5, we believe. That's our estimate. So it's the number of customers multiplied by the midpoint. 6 times 1.5, 10 times 4.5, which is 45. That one is 6, is 9. You can do this on a calculator on your head. It's 42, 45 again. 2 times 10.5, is it 21? Yeah, and then 1 times 13.5. So in an exam you cut down on your writing. Well, you got to put the methods in. So yeah, I'm not going to say cut down on your writing, that would be bad. But yeah, write down everything that you can. But if you, yeah. Okay, so the estimate of the mean, so it's 9 plus 45 plus 45 plus 21 plus 13.5. So it's this total here divided by this total here. We need those 2 totals. And then divided by 6 plus 10 plus 6 plus 2 plus 1. Sometimes they tell you this total in the question, but it doesn't here, so we'll have to do it separately. So calculator, 9 plus 45 times 2 is 90, plus 21 plus 13.5. 133.5 divided by 16, 22, 23, 24, 25. Okay. Just checking my totals here. Yes. So we do 133, 45 divided by 25. 5.34 minutes. We don't need to turn it to seconds, so we'll just leave it like that. So explain why it's not possible to use the information from the table to calculate the exact value of the mean. It's like, how to word this? We don't have the exact times taken by each customer. Okay, we estimate each customer's time using the midpoint of the group of the time taken group, which don't need to. We use the midpoint. It's only one mark. We don't know the exact times. We'll estimate them instead. Jeet is growing carrots from seed in his garden. He plants 28, but only 12 grow. Jeet says the probability of one of my carrot seeds growing is 3/7. Show that he's correct. So the probability of growth is, and it's 12 out of 28, and this cancels down. So what we can do, top and bottom divide by numerator and denominator, divide by 4. So we divide by 4 there, divide that one by 4, so it's 3/7. Correct. Yeah, 3/7. A farmer uses this probability to calculate the number of how many carrot seeds he should plant to grow 10,000 carrots. Okay, so if he wants 10,000, we can say, if he plants n seeds, okay, 3/7 of n will germinate, because 3 out of 7 is going to germinate. So he planted 28 and he only got 12. 3/7 of 28 is 12. So that's using this here, this ratio. And that has to be equals to 10,000. Okay. So we multiply by 7. And then divide by 3. And then we divide 1, 2, 3, divided by 3. So I've got 23,333.3 recurring. So it's going to have to, 23,333.3 recurring. So he's going to have to plant 2, 3, 3, 3, 4 seeds. Okay, to make sure he can get 10,000. Yep. Explain why it may not be sensible for the farmer to use Jeet's experimental probability to calculate the number of seeds he should plant. Well, Jeet's growing them in his garden, and a farmer might be using a big field. So to be fair, oh yeah. So the environmental conditions at the farm may differ from those in the garden. I think they will actually, may well. But also, he's only used, his data is just from 28 seeds. And there's a big difference between 28 and 10,000. Also, 10,000 is much greater than 28. So, you could say the sample may be too small to draw. So the sample size, it's much greater than 28, the sample of 28. I don't know if I should be a bit more definite. It may well be. It might be all right, but it might not be. Let's be a bit more definite. The environment will differ from those in the garden. So, probability of growth will change. Let's be definite instead of being, I mean, in real life, you never know what's going to happen, but let's be definite. The sample of 20 is too small to draw conclusions about for a sample of size 10,000. Okay, that notation is a bit, there we are. Okay, 1 mark. Right, the company makes sweets. Sweets are put into packets. Here are some facts. 1.47 times 10 to the power 7 sweets are made every day. 3.5 times 10 to the power 5 packets of sweets are produced every day. Calculate the mean number of sweets in one packet. So we've got 3.5 times 10 to the power 5 packets. And you want to see this way around. Well, do it this way around. So the 1.47 times 10 to the 7 sweets get shared out among 3.5 times 10 to the power 5 packets. I'm going to put that to my calculator. 1.47, I'm using the times 10 to the power x button. So then I'm putting a 7 next to that 10. And then divided by 3 and then I'm going to do open bracket 3.5 times 10 to the power 5. And that's going to be 42. So it's 42 sweets in one packet. Okay, so I use the times 10 to the x button. So actually I didn't need bracket. You don't need brackets around there if you use that button because it deals with it properly. But if you use the, there's also the x with a square there. You could use that button as well. But yeah, so it's just be careful. Okay, so it's 42 sweets in a packet. You can think of this sum as, you want to know sweets per packet, so you do the sweets number divided by the packet number. Okay, if you use your fractions button, it's 1.47 times 10. I'll actually write out exactly what I typed into my calculator. With the fractions button, you can do 1.47, and then I've done 10 to the x, and then 7 divided by 3.5 times 10 to the x 5, and then equals, and that comes up with 42. Okay, sweets are made on 288 days each year. Calculate the number of sweets made each year. Give your answer in standard form. So we've got 1.47 times 10 to the 7 sweets for 288 days. So 1.47 times 10 to the 7 times 288. So on my calculator, that's your normal keys, times 10 and then 7. Just checking what you need to put into you. Just checking the So that, like that, worked through on my calculator. I didn't need to put brackets in. It's 1.47 times 10, and that number is there. That's a 7, and then times 288. And it gives your answer in standard form. Well, the calculator gives it as 42336 with 5 zeros. So with standard form, we need a number between 1 and 10 to represent these. So it's 4.2336 to represent the non-zero digits to the front. Not all the non-zero, there could be a 0 there, but before this row of zeros starts. And it's going to be, that's multiplied by 10 to the power 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where that comes from there. Yeah. The company has 152 machines for making the sweets. Each machine operates for 15 hours per day. Okay. Calculate the number of sweets made by one machine in 1 hour. Give your answer as an ordinary number correct to the nearest 10. So we've got 1.47 times 10 to the 7 sweets made every day. Okay. And it's 152 machines. So we divide by 152. And that's how many sweets. I'm just doing that sum now, divided by 152. That's how is the number of sweets per machine. And it comes up as 9, 6, 7, 10 point. Oh, that's not working. 9, 6, 7, 10.5, etc., etc., etc. Okay, so that's the number of. Oh, look, we've got the sweets on the top and the machines on the bottom, so it's sweets per machine. Okay, and then I'm keeping the answer on the calculator because that's going to preserve this accuracy here. And then each of these machines operates for 15 hours per day, so we need to sweets per machine, and that's each day. Right. So then we've got to do the answer on the calculator and divide by 15 to get the number of sweets per machine per hour. And it's 6447.3. 6447.3, etc., etc. And we want our answer to be, so I've done all that, ordinary number correct to the nearest 10. So I'm going to say, so we don't need the decimal, we don't need the units because it's there, because they're the tens. So it's 47, so to the nearest 10, 6450 to the nearest 10. State one assumption you've made in part C, part 1. Okay, so what we've assumed is that all these 152 machines all work at the same speed, the same capacity, etc., etc. So we've assumed that we have assumed, well, in fact, you don't need to write that in an exam. All machines produce the same number of sweets. Produce the same rate of sweets. Per hour. So some might be faster or slower. We don't know if we've got big machines, small machines. Okay. You know, and that they all work. Sometimes they might break down for an hour or two. I don't know. Anyway, we don't need to elaborate. Right, question 6. 2 bags each contain only red counters and yellow counters. In bag A, the ratio of reds to yellows is 1 to 4. In bag B, quarter of the counters are red. Sharon says, the proportion of the counters that are red is the same in both bags. I explain why Sharon is not correct. Okay, in bag A, we've got the reds is the first one. 1 out of 1 plus 4 are red. So it's 1/5 are red. So in brackets, 4/5 are yellow. Okay, so it's not that number divided by that number. If you're looking at the proportion of one of these in that bag, it's the number linked to that colour that we're looking at divided by the total of the other two numbers. Okay, and then 1/5 is not equals to 1/4. Okay, so the number of the counters in the two bags is the same. Complete the table to show how many counters of each colour could be in the bags. I'm glad it said could there. Okay, because I thought, well, with its proportions, we could go on. Okay, so the ratio of red to yellow is the number of counters in the two bags are the same. So I'm feeling like I want to make everything into 100. I don't know why. Is that not work? So in this one, 1/5 are red and 4/5. 1/5 in bag A, 1/5 are red, 20, 4/5 are yellow, 80. And then in bag B, a quarter of the counters are red, 25 and 75. So then there's 100 in each. Okay. That's not as yeah. So it's 1 to 4 for red to yellow here. 1 to 4. So 20. A fifth is 20 out of 100. 4/5 is 80 out of 100. And then in bag B, a quarter of the counters of red. 25 to 75. Okay. Right. In another bag, bag C, the ratio of reds to yellows is 3 to 4, sorry. If 3 of the red counters are removed from bag C, the ratio of red to yellow changes to 3 to 5. How many yellows are in bag C? Okay. Right, so we've got bag C. If we start off as 3 to 4, then if we take away 3 counters, 3 of the reds, that's it, if it was taking away 3 of the yellows. We take away 3 of the reds, the ratio of red to yellow is 3 to 5. Okay. And then, so this is red to yellow. If we take away 3 reds, it changes to 3 to 5. Okay, so let's start. Let's say, no, this is a ratio, so it's not exactly 3 to 4. It could be 30 to 40, it could be 6 to 8, etc., etc. So we can just say, in this bag here, bag C, in bag C, the ratio is actually 3x to 4x. Okay, because it's multipliers of 3 and 4, and if we then if we do 3x take away 3 to 4x, this is actually 3 to 5. Okay, so I'm feeling like wondering if I need to introduce another letter or not. And I was going to introduce a Y, but I've got a capital Y there. I'll just call that yellow and write that out in full. So 3y is 3x minus 3. And this is equivalent to 3y to 5y, and 5y is equivalent to 4x. That's equation 1. Equation 2. From equation 2, we get that y is 4/5 x. Divide both sides by 5. And then we substitute into equation 1. So 3 times 4/5 x is 3x minus 3. So divide both sides by 3. 3 times x minus 1, so divide that by 3. Multiply by 5, so 4x is 5x minus 5. And then subtract 4x from each side, so 0 is x minus 5, so therefore x is 5. That's our key. So if x is 5, go here, we've got 15 to 20 in the original bag. And then that's 12, because that goes down to 3, and we've still got 20 there. So this is the original bag. I found x is 5, 15 to 20 there. We take 3 out of that bag, so that bag goes down to 12. But then that one stays the same, so that's still 20. If we simplify this one, I'm checking here. Simplify this one, they both divide by 5, 3 to 4. Simplify this one, they both divide by 4, 3 to 5. Okay, and what do we need? How many yellow counters in bag C? 20. Right. Gustavia invests £520 for 6 years in a bank account paying simple interest. At the end of the 6 years, the amount in the bank is £629.20. Simple, not £1. Calculate the annual rate of interest. So we do £629.20 minus 520, so £109.20. Okay. That's how much interest Gustavia has made in 6 years. So then we divide it by £109.20 divided by 6. So £18.20 per year, per annum. Calculate the annual rate of interest. And it's a percent that we need. So £18.20 the first year is £520. Okay, so this 520 generated £18.20 interest. So it's that divided by that times by 100. And it comes up as 3.5% interest. Okay. The design below is made from 2 sectors of circles, centre O. Calculate the perimeter of the shaded part. Give your answer correct to 3 significant figures. Okay, so 45 degrees is 45 divided by 360, that proportion of a full circle. So it's 1/8 of the full circle. Okay, so the full circumference of a circle is 2 pi r. Okay, that's for the circle. So the circumference of this arc is 1/8 times 2 pi r, because we've only got, so that's these bits here. These bits here is 1/8 of a full circle because of the 45 degrees. Okay, so that's going to be, and then the 1/8 and the 2 is going to be 1/4 of pi r. Okay, so we need the perimeter of the shaded part. So that part is 3.5 centimetres, because that's there. This radius here, because we need the radiuses to work out that one there. So that one there is going to be 1/8, sorry, 1/4 of pi times this radius of this circle here, and that's going to be 2.5 centimetres. And then this arc here is going to be 1/4 times pi times 6. Okay, so what we need to do, 3.5 times 2, which is that bit and that bit, plus 1/4 pi, and that's going to be 2.5 for that one and 6 for that one. I was going to write that as with a bracket, but I'll write it out in full. 1/4 pi times 6. And we want 3 sig fig. So 3.5 times 2, which is 7, I knew that already, plus 0.25 pi times 2.5 plus 0.25 pi times 6, 13.6. 675, etc., etc. And we've got to round it off to 3 significant figures, which is there. So it's 13.7 to 3 sig fig. Oops. Right, the diagram shows the position of 2 towns, Ampton and Bisham. The bearing of Bisham from Ampton is B degrees. The bearing of Ampton from Bisham is 6B degrees. Right, so I'm going to join these together. And then this first one here, Bisham from Ampton. So here, where it's from, you start from the north of the place where it's from, and you measure clockwise round, and that's going to be B degrees there. So that's that one on the diagram. The bearing of Ampton from Bisham is 6B. So that means we'll put the north at Bisham here, oh it's already drawn, and then we measure clockwise round, and that's 6B degrees. Calculate the 3-figure bearing of Ampton from Bisham. So we actually need to work out what 6B is. We actually need the 3-figure bearings. We actually want the actual degrees of Ampton from Bisham. So it's that there. Okay, so what you've got to remember here, we've got to set up some equations basically. Right, when we've got these here, this angle, I'll call this A, to go with the B. Okay, what we've got, A degrees plus B degrees is 180 degrees. Okay, so because these are both pointing north, these lines are parallel. Between parallel lines, they add up to 180 degrees. And then we've also got A degrees plus 6B degrees is 360 degrees, because that's a full circle around there. So those two add up to 360. Okay, so the difference, if we do 1 and 2, if we do 2, take away 1, we've got 5B degrees is 180 degrees. So B is going to be 180 divided by 5, which is 36 degrees. Okay, so we want the 3-figure bearing Ampton from Bisham. So the actual answer is 6 times 36. It's got to go around there. it's 100 to 116 degrees. Okay. Six B is the answer. Okay. Number 10. The graph shows the world population in billions between 1951 and 2015. That's 1951. There's 2015. Use your graph to estimate the average rate of growth of the world population between 1915 and 2015. Give suitable units for your answer. Okay, so we're given data in billions. Okay, so we don't need to go to too many significant figures. And the growth is going to be the change in population divided by the time taken. Okay, so here, this one is there. So it's 7.4. I'm just going to keep it in billions for now, just to see what we get. The change, it's gone from 2.6. Look there, because there to there is 3, so they're going up in 2s. Each little square is 2. 2.2, 2.4, 2.6, 2.83. And there, 7.2, 7.4. And then the number of years taken to that change is 2015 minus 1951. So 7.4, we're in billions, we're working in billions, minus 2.6, so it's 4.8, sorry, I'll put the 4.8 in 2015 minus 1951 over 64. So 4.8 divided by 64, 3/40ths, 0.075. Use the S to D button to change the fractions to decimal. I said 3/40ths and then I pressed S to D. Okay, 0.075 billion. And now we're in the UK, and a billion in the UK is 1,000 million. Okay, so a billion is 10 to the power 9 in the UK. Yeah, it does change, but I'm going to stick to the UK because it's a UK paper. So, and we want well, I could just say it's 0.075 billion because that's what they're giving me. But anyway, I'm going to multiply my answer by 10 to the 9. So I'm using my times 10 to the power 9. I'm putting a 9 in. Oops. Right, 0.075 times 10 to the power 9. So I've got it as 75 with 6 noughts. Okay. So that's the change. So every year. Okay. And is it sensible? I would say it is, yeah. To have that decimal place there. I would say that was fine. Okay. Ruben is playing a matching game with these cards. 9 of them. 4 circles, 5 squares. Get that there. 4 circles, 5 squares, yeah. He turns over the cards and shuffles them. Takes a card and keeps it. Takes the second card. the cards are different, he wins the game. Complete, and he keeps it, that's important there. If the cards are different, he wins the game. Complete the tree diagram to show the probabilities for each card picked. So, 5 out of 9 for the circle, or the square, we've already counted those up. Right, and he keeps it. So in this second round, they're all out of 8, because he's keeping one of them. Okay, so if he starts off with 4 circles and he gets a circle, he's gone down to 3, because he's kept one of them. So he's still got his 5 squares in that outcome there. On this branch, if he gets a square, he's still got the original 4 circles, but his squares have gone down to 4. Okay, and what's the probability that he wins the game? If the cards are different, he wins. So circle to square, that's a winner, and square to circle, that's a winner. So he's got 4 out of 9 times 5 out of 8 for that first branch. And this branch is 5 out of 9 times 4 out of 8. And you add up branches that you want to combine together. So it's 5 out of 9 times 4 out of 8. So this is 20 out of 72 plus 20 out of 72, which is 40 out of 72. And now 40 divided by 72 on my calculator, 5/9. Okay. If it was non-calculator, you'd divide top and bottom by 8. Right, a sequence is defined using this term-to-term rule. un plus 1 is the square root of 2un plus 15. If u1 is 5, find u2. Right, oops, come back. What happened there? What happened there? There we go. Right, u1 is 5, u2. So this means like if you the next term, because this is n plus 1, well we've got a 1 here. So the next term is when we've got u2 there. So it's the square root of 2 times the u1. Yeah, so u2 is 2 times u1 plus 15. Okay, so it's going to be the square root of 25, which is also 5. Yeah. That's interesting. Yeah, so every u3 is going to be 5 and u4 is going to be 5. Okay. Right, another sequence is defined using this term-to-term rule. un plus 1 is kun plus r, where k and r are constants. And then we've got u2 is 41, u3 is 206, and u4 is 1031. Find the value of k and the value of r. Okay. So, u2 is, we don't know u1, so I can't use u2. I'm going to say u3 is k times u2 plus r. So put the numbers in. This is because this subscript here has to be 1 more than the subscript there. Well, I started writing 2, but I'd need 1 for there, and I haven't got anything about 1. So I've gone on to 3 in terms of 2, and then I can also have 4 in terms of 3, so I'll write that underneath here as well. So I'm going to put the numbers in now. 206 is k times 41 plus r, and 1031 is k times u3, 206 plus r. Okay, so u3, 206, k and r we don't know, u2, 41, u4, 1031, k and r we don't know, and u3 is 206. Now, so this is simultaneous equations, call that equation 1, that equation 2. These r's here and here. So if I do 2 take away 1, we'll eliminate the r and we'll get a relationship we'll get something where we can work out K. So I'll do equation 2, take away equation 1. So it's going to be 1031, take away 206. That's going to be 206k minus 41k. And then the r's will cancel because it's 1 r there. I'll write it in, but it'll be plus r minus r, so they'd cancel. Okay, so 1031 minus 206 on the calculator, 825. 206 minus 41 for the k's, 165k. So k is 825 divided by 165. 825 divided by 165. K, which is 5. K is 5. And then we can substitute for k in 1. Doesn't matter which one we pick. 206 is k times, well, k is actually 5, so let's put 5 there. 5 times 41 plus r. So therefore r is 206 minus 5 times 41, which is 1. Okay, and let's just check with check with 2. 1031, well, what I need to have is that k times 206 plus r has to make 1031. 5 times 206 plus 1 does equal 1001. So I'm happy. Okay. A model railway is built using the scale 1 to 87. On this railway, the distance between the rails is 16.5 millimetres. Calculate in metres the distance between the rails for a full-size train. Okay, so that's going to be the model, and that's going to be the real life. So the real life is 87 times bigger than the model. So in millimetres, we've got 16.5 times 87 for the real life gap between the rails, 16.5 times 87, which is 1435.5 millimetres. So in centimetres, it's going to be 1435.5 divided by 10, because every 10 millimetres makes a centimetre. I can't believe I did that on my calculator. 143.55 centimetres. And then for metres, you do 143.55 divided by 100, because every 100 centimetres makes a metre. So it's 1.4355 metres. Okay. B. The volume now, that's important, of a full-size train carriage is 220 cubic metres. Driver calculates the volume of the model train carriage to be 334. Is he correct? Centimetres cubed. Oh, this is a complicated. Oh, it's up. Yeah. 3 marks. Correct to 3 sig fig. Is he correct? Shall you decide? Okay. So first of all, what we've got to remember, 220, well, let's write 1 metre cubed. If you think about a metre cubed, there, 1 metre, that's 100 centimetres. So actually 1 cubic metre is 1,000,000 cubic centimetres, because it's 100 times 100 times 100 times 100. Okay, so we've got 220 cubic metres, which is going to be 220, 1, 2, 3, 4, 5, 6 cubic centimetres. Okay. Now, what we've got here is the distance, the scale 1 to 87. That means each length is 87 times bigger in real life. So to scale it down, we've got to divide by 87. But because it's a volume, the volume scale factor. Now the volume is made up of the 3 lengths, like I've shown over here. So the volume scale factor is 87 cubed. Okay, so we actually need to do divide 220 million divided by 87 cubed. And that comes up as 334.09, etc., etc., cubic centimetres, which is 334. So 3 significant figures. So Trevor is correct. Okay. Okay, so what we've got here, well, yeah, what I was going to say, if it was an area scale factor, it'd be 87 squared. But that's what I wanted to say. So that if it was just the length, it's 87. If it was an area, which is in this question, it'd be 87 squared. And the volume scale factor is 87 cubed. Right, number 14. The diagram shows a cross placed on a number grid. L is the product of the left and right numbers of the cross. So that would be 34 and 36 in this case. T is the product of the top and bottom, so that means multiplied together. So that's in this particular one. In our example, L is 34 times 36, T is 25 times 45, and M in our example is 35. Right, so it says show that when M is 35, which is what we've got here, L minus T is 99. Okay, so L minus T, I've already done some of this working out already. 34 times 36 minus 25 times 45. Calculator. 25 times 45. I've run that through the calculator. 99. 2 marks. I say that 5 marks. Prove that for any position on the cross on the number grid above, L minus T is 99. Okay, so let's think a random M. Let's just put, there's this cross. We've got a random M. So wherever we are, this M, this one is always, we're gonna label all these points of the cross, if you like, in terms of M. So this is 10 less than M, this is 10 more than M, this is 1 less than M, and this is 1 more than M. Okay, so that is M minus 1, that is M plus 1, that is M minus 10, that's going to be M plus 10. Because it's on the number grid that's set up in 1's going that way and 10's going down there. Right, L minus T is going to be left. L is left times right. So it's M minus 1 times M plus 1. And then minus T, which is M minus 10 times M plus 10. Okay. Right, so I know this is the difference of 2 squares because it's same letter there and there and the same number there and there, but with a change of sign. And I know this actually comes out as M squared minus 1 squared minus M squared minus 10 squared. So it's M squared minus 1 minus m squared plus 100. If you multiply these out, you'll get m squared minus 1 minus m plus m, they cancel out. M squared minus 100 minus 10 plus 10. Minus 10m plus 10m, so they cancel out. Okay, and then this minus m squared, and then minus makes plus 100. So the m squareds cancel out, so minus 1 plus 100 is 99. Right, number 15. The following formula is for the area of the curved surface area of a cone. A is pi RL, R is the radius, and L is the slant height of the cone. So we've got a cone. I think of it like an ice cream cone. Okay, the curved surface area of a cone, which is going to be the area of this here. Pi RL, pi times R times L. R's radius, L's the slant height of the cone, so that's going to be L there, and then R is going to be that distance there. Calculate the total surface area of a cone with radius 5 and slant height 12. So in terms of pi, I understand it. It's not just an ice cream cone. We've got a top as well. Otherwise it would be too easy. Okay. So the total surface area of the cone, so that this one here, the area of the circle on the top is pi r squared. Okay, so that's a bit more interesting. Okay, so the total surface area of the cone, the area of the circle, the area of the circle, the area of the cone. Anyway, so the total area is pi r squared plus pi r L. So it's pi, and r is 5 squared, pi times 5, and the slant length is 12. So it's just putting all these numbers in. That radius there goes in there and there, and that L is there, goes in there. Okay, so this is 25 pi plus 60 pi, so it's 85 pi. Doesn't say to round it off or anything, so let's just leave it as 85 pi. Right, A, B, C, D is a parallelogram, A to B to C to D. B to D is A, vector A. A to D is B. F is the midpoint of BC. G is the midpoint of DC. And A to E is 3 times E to B. Right, I think I've got all that then. Right. So this here, yeah, AE is, so that line there, that means that distance there is 3 times the distance there. So if that was 30, that would be 10. If that was 6, that would be 2, etc. Write down simplified expressions in terms of A and B for A to B. Okay, so to get from A to B, we're only allowed to use A and B. The bold ones means it's the vectors that we're using. So we've got to do a B, but then we've got to go back along here because we want to go from A to B. So we do a plus B minus an A. Okay, so it means start at A and finish at B. Okay, so we do a B and then minus an A. Right, E to B. There. We've got to use this ratio now though, because E to B. So we need to do that one, and then we do that one. Okay, So because this is in a ratio of 3/4, 1/4, so this is going to be 1/4 of B minus 1/4 of A. I don't know if that... So I just need to feel I need to explain that a little bit more. This means that A to E to E to B is 3 to 1. Okay, so if we're going to start... so it's in the ratio of 3/4 to 1/4. Okay, so that's 3/4 of that length, that's 1/4. So because we've got A to B, it's B minus A. To go from E to B, it's just 1/4 of that. So it's 1/4 of B minus 1/4 of A. Yeah. So E to B is that there. Come from that ratio with that 3. Happy with that explanation. Right. Show that E to F is 1/4 of 3B minus A. Right. E to F. Just rub out these bits so don't get muddled in. E to F. Okay, so to get from E to F, we've got to do that bit. That's where we want to go. And then that bit. Okay. Right, E to F. To go from E to F, it's E to B plus B to F. And E to B we've got there. So it's 1/4 B, oops, lowercase b, minus 1/4 A. And then B to F. Now this is a parallelogram. So because A to D is a B, B to C is also B, and F is the midpoint, so B to F is going to be 1/2 a B. Okay, so it's plus another 1/2 a B. So in the B's we've got 3/4 of a B, we've got 1/4 plus 1/2, minus 1/4 A. And there we are. And that's what we need to show. Prove that E to F and A to G are parallel. So we've just worked out E to F is 3/4 B minus 1/4 A. We now need to do A to G. So I've got that one. A to G. Let's see. So G is the midpoint of D to C. So G is also the midpoint of A to B. D to G is going to be the same vector as A, the midpoint of A to B, which we haven't got it for. But the midpoint of A to B so I've got A to B there, is B minus A. So the midpoint is going to be 1/2 of that, 1/2 B minus 1/2 A. Okay, and I'll just show you that with a diagram. So we do 1/2 of the B minus 1/2 of the A takes us to the midpoint of AB. Okay, and it's 1/2 of that basically. Okay, so A to G is actually going to be a B plus this, which is parallel to this. So it's actually B plus 1/2 B minus 1/2 A. A to G, A to D plus D to G. Okay. Now d to g is the same as a to d plus a half of a to b, because of the parallel there and there, halfway. Okay, so a to d is b, and then half of ab is a half b minus a half a. So this is actually going to be 1.5b minus 0.5a. And then if we look at e to the f, this is actually 2, comparing it here, it's 2 times 3/4 b minus a quarter a. So it's actually 2 times e to f. So because a to g is a multiple of e to the f, two vectors that are parallel to each other are multiples of each other. So we say hence ag is parallel to e to f. How many questions are there? There we are, 2 to go. Right, diagram shows a circle centre the origin. Write down the equation of the circle. So if you've got a circle positioned at the origin, and look, the radius is 10, so what the form is always x squared plus y squared is r squared. So in this case, it's x squared plus y squared is 100. P has coordinates, x is 8, y is minus 6. So 8 squared plus minus 6 squared, 64 plus 36 is 100. It satisfies x squared plus y squared equals 100. Therefore lies on the circle. Find the equation of the tangents of the circle at the point P. Oh, I was looking for P on the diagram. P is actually 8 minus 6. It's about there. So we want the equation here. Okay, and this here. If you remember, a tangent makes a right angle with, that's the point, 8 minus 6. A tangent makes a right angle with the radius. Okay, and if you also remember, I'll put that in the diagram, if you've got two perpendicular lines as we have here, if M1, if two straight lines, if line 1 is perpendicular to line 2, then M1 is the negative reciprocal of the gradient of the line M2, of the line L2. So these are the facts that we're going to use here. So from looking at the radius first of all, well, the radius that goes from 0, 0 to 8 minus 6, this, call this one L1, that's got the gradient 1, change in y, divided by the change in x, so it's minus 3/4. Okay, so we'll call this one L2, and M2 is going to be the negative reciprocal of M1. So we change the sign, and then we invert the fraction, 4/3. So we've got that for the L2, which is the one that we want, the tangent, it's going to be M 4/3 x plus c, because it's a straight line. And L2, let's call it y equals 4/3 x plus c. A bit more typical notation. L2 is y is 4/3 x plus c. So to find the c, we've got to substitute, and x is 8, y is minus 6. So minus 6 is 4 times 8. I'm seeing Yep. Oh. Substitute. Y is -6, x is 8. So -6 is 4 times 8 over 3 plus c. So that's -18 over 3 is 32 over 3 plus c. So take 32 thirds from each side. C is -50 thirds. So putting it all together, we've got y is 4 thirds x -50 thirds. Okay, I've got one question left here. Just checking my answers as I go along. It's got a little bit messy, but there we are, that's the answer. If it does get messy, make sure you put your answer in the answer box, because I want the examiner to give you the marks. 18. Diagram below shows a 1 centimetre coordinate grid. I agree with that. By that it means all these gaps are 1 centimetre, and they are. Find an inequality that defines region A and another one that defines region B. Right, so we need to work out these lines. So this line here, this is the line y equals 2. Everywhere on here, like this coordinates, 1 across, 2 up, 2 across, 2 up, 6 across, 2 up. The way we describe that line is that it's y equals 2. This line for B, let's do so region A. No, I'll come back. We need the lines first of all. It's going to be, well, in A, the y's are going to be less than or equals to 2. Okay, and it's because it's a bold line, it's allowed to be equals to 2. If it was dotted there, it would be just less than 2. Okay. So now we need the line for B. I'm not going to try and squeeze this in up here actually. A was quite easy, you could just do it on the diagram because it's y equals 2. So the line for the boundary of B it's a line y equals mx plus c. Okay, now we can't, you could work out the m and substitute some points, but I've already done that in that question up here, worked out the m and substitute points. So I'll do it a second way just to show you something else. So this line, it goes through x is 8, y is 2, and x is 5, y equals 8, and then it's simultaneous equations. So if we substitute x is 5, y is 8, and that's 1 point there, x is 5, y is 8, x is 8, y is 2. Okay, so we've got 8 is, x is 5, or 5m plus c, and then that's that point, and then that point there, 2 is 8m plus c. Okay, so actually I've done these before in another question as well, but anyway, never mind. So if I do 2, take away 1, we've got -6 on the left is 3m, and the c's cancel out, so m is -2. So this line here is y is -2x, and that's because, look, for 1 across, it is going down 2. That's what we'd want actually, 1 across down 2, 1 across down 2. So y equals -2x. And then if we substitute into 1, we get 8 is 5 times -2 plus c. So c is going to be 18, which is 8 plus 10. That's 10, -10. Add it to that side. Okay, so the c is going to be plus 18. So the line for the boundary here is y is -2x plus 18. Now the shaded region, it's above the line. Okay, you've got things like, I don't don't know if x is 8, y is 100. That would be shaded because it's here. Okay, so these y's have to be greater than or equals to minus 2x plus 18. Okay. Next one. Shade on the region the inequality given by y is greater than or equals to 6. So we start by drawing the line y equals 6. And then we've got to shade. So I shade that one there. Actually, with my fancy tools, I can do it with this. Make it grey like all the rest. But there we are. There we are. So it's there. Okay. Right, a fourth shaded region given by the inequality. Is this the last question? Oh. Y is greater than or equals to kx plus 2 is added to the region. The unshaded region now has an area of 23 centimetres squared. Find the value of k. Okay, so all this is, so y is greater than or equals to kx plus 2. Okay, so basically, I'm just going to draw this diagram down here because I can draw it in rough and explain why I've drawn this trapezium here. Okay, so that's not very good. Right, if this line, this new line, if we draw the line, this is going to be y equals kx plus 2. Okay, and it's going to come from when x is 0, y is 2. Okay, so we don't know the steepness of the line, that's just a rough guide, but we do know that it goes through 2 at the start, because that's when x is 0. So it could be like that, it could be quite steep. I've just drawn a rough one, but we've definitely got all the other bits. Okay, we know that this one here, this is 8 across 2 up. So that's 8 across and 2 up, yeah. And we've also got that other one up there, here, which is 6 across, 6 up. But we don't know what that one is. Oh, we know it's got some unknown x. Let's call that unknown x P for a point, but we do know that's got height 6 because it's got this line y equals 6. Okay, so we need to work out the P value that gives this area here equals to 23 centimetres squared. Okay, so we don't know that bit there. We can't work out this part though, because we've got enough to work out these, or have we? Oh, think. The total area is 23. Right, when we've got a trapezium, that distance is 8. That distance is 6 minus p. Okay, and that 6 minus p comes from that 6. Take away that p, because it's, those 6's are for the height. It's the grey p's. The distance there is the change in x. So it's 6 minus p there. Right, the area of a trapezium is half the sum of the parallel sides times the distance between them. That's the way the formula goes for an area of a trapezium. So it's a half. 8 is the base there, plus 6 minus p. We need a highlighter. So we've got 8 there and 6 minus p. 8, 6 minus p. And the distance between them, it's the change in the y's. So that one's 6 high and that one's 2 high because of there. So that distance there is actually 6 take away 2, which is 4. Okay, so it's getting a bit messy here. Half, okay, the sum of the parallel sides, 8 across there, 6 minus p up there, times the distance between them. Well, that's this line's at height 6, this line's at height 2, so it's 4. Let me make that one orange. That's come from those there. And that is equals to 23 centimetres. Okay, so let's simplify this. The 4 and the half there, that can be 2. 14 minus p inside the bracket is 23. So that's the area of a trapezium is equals to 23. So this means that 2 times this bracket is 23. So the bracket is 11.5. So therefore 14 take away so that makes 11.5. P is 2.5. Just check all my solutions in front of me. Right. What a different answer from here. Half a plus b times h is 25. Oh. Oh. Oh look. Oh no, it is 6. 6, B6. Just check the, oh annoying. Ah, yeah, P is 2.5. It's not P that I need to find, isn't it? It's K. Yeah, right, so P is 2.5. Okay, so I'm going to transfer all that information onto this diagram here. I've done it a different way from my colleagues, so. Right, P is 2.5. So this line looks like this. Okay, so I've worked out that it goes from 2.5 across, 6 up. Not across, 2 up. Okay, so the K that we need here is actually the gradient of the line connecting these 2 points. Ah, that's it, so I haven't quite finished. Gosh, how many points? 5 points. So the gradient K, it's going to be, it's the gradient K of the line connecting, this is what we need, 0 across, 2 up, and 2.5 across and 6 up. Okay, so we've got to do the change in y over the change in x because it's the gradient. Gradient K is the gradient, I've got my words the wrong way around, of the line connecting those. So it's the change in y over the change in x. So it's 6 minus 2 divided by 2.5 minus 0. So it's 4 over 2.5, So it's 8 over 5, which is 1.6. Hooray!